Hello friends, welcome to my YouTube channel. In the previous video we did introduced the probability, and today we will try to understand the axioms given by N Alamogorov in 1933, on which that formally was this probability theory was developed and became very helpful and handy, that could be used in various science and mathematical faculties. So today what we had done in the last lecture was that if probability of an event could be defined as the number of event of A, or the number of elements of event A divided by total number of elements of a subset S. So where A is the event and S is basically the sample space. Okay. Well, the first axiom that was given by N Alamogorov in 1933 was that the total probability of a sample space, if you try to calculate the total probability of a sample space, that should be equal to 1. So that sample space may be consisting of many elements like A1, A2, A3, etc. And if you try to add all the probability of these samples, these elements up to an, so PS basically is the sum of a probability of all these elements or events. So the probability of A1 and probability of A2, likewise probability of AN, or you can write probability of all these elements. So A1 sum of A2 sum union of A3 up to AN, that should be equal to 1. So that is the first axiom that was given by him. Second axiom what he introduced was that the probability of a particular event, it can be A1, A2 or any element that was in sample space, so the probability of that particular event should be greater than or equal to 0. It means it is non-negative, right? The probability of a particular event can be non-negative. That was the second one. So in a way you can say that the probability of A cannot be less than 0. So that cannot happen. So that was the second assumption, or the axiom. Well, the third axiom that was given was that if suppose there were two elements or two events in a particular sample space S, so A1 and A2 if suppose are the two elements, then the union of these two elements should be probability of A1 plus probability of A2, where it is considered or assumed that A1 and A2 are mutually exclusive events. So basically these two are mutually exclusive, though the probability of A1 union A2 can be written as the sum of probability of A1 and probability of A2. Now the question arises that if these two events A1 and A2 are not mutually exclusive, then what would happen? So in that case, the total probability or the summation of A1 union A2, so A1 union A2 can be written as summation of probability of A1 and probability of A2 minus of intersection between A1 and A2. So basically this is the sign of intersection. So that we will also understand